All right, good afternoon. Happy Thursday. First thing I want to talk about today is we're going to have an exam on Tuesday, 8 a.m. on 3.1. So I want to take any questions you might have about 3.1. And then I'm going to turn right to the electric circuit and try to explain it better than I did yesterday. So I have it written down this time. Questions about 3.1. All right, then let's take a look at the electric circuit.
I think we're fine.
Can't hear you.
I was just saying, I don't think we have any questions.
Okay. All right, so I'm on page 131. And I'm going to draw the circuit up here again. So that symbol represents the resistor, which is 4 ohms. And this coil represents what? What's the coil represent? Yeah. And then what does this represent?
Capacitor.
Yeah. And then they're showing the voltage here, which is 120 volts. So the components are these 3 components here, and the voltage of the circuit is 120 volts. So the first thing we did yesterday is we found the total impedance. Now, impedance is resistance. So it's opposition to the flow. So the impedance is denoted by the letter Z, and a total would be the resistor, which is always a real number. What was this again?
The inductor.
The inductor is always a positive imaginary, and what's that?
The capacitor?
The capacitor is always a negative imaginary, and when you combine like terms, you get 4 minus 2i. All right, now there's Ohm's law. Now remember that symbol means ohm. Ohm's law is for AC electric circuits and AC causes, well, an AC power, we'll read that in a minute. Ohm's law for AC electric circuits is voltage equal to times Z where V is voltage, I is current, and Z is impedance. Okay, so read with me in the middle of the page, please, on page 131. A diagram of an AC, which is alternating current. The diagram of an alternating current electric circuit along with the impedance measured in ohms of each component in the circuit. AC power source, which is shown on the left in the diagram and labeled 120 volts, causes electrons to flow through the circuit. And impedance is a measure of each component opposition to the electron flow. So what we're going to do is, I should say one more thing. What's given in every problem is the current. So they will give you the current. So in this problem, the current of the circuit is 24 plus 12I amps. And that will be used throughout this problem. So we're going to find the voltage of each component. So we're going to find the voltage of the resistor, which is V equals I times Z, which is going to be I, which is the current that's given, and Z, which is, it's not going to be the total impedance, it's just going to be the impedance of the resistor, which is 4. So yesterday, I think I wrote the total impedance, but it's just the impedance of the resistor. Now you distribute. So you get 96 plus 48I. So that's the voltage of the resistor. So now we're going to find the voltage of the inductor. Same formula. Is equal to, and I'm just going to write this being I, right? It's the current, which is 12I, which is given in the problem, times the impedance of the inductor, which is a positive 3I. So that's going to be 3 times 24, which is 72I plus 36I squared. So this turns out to be 72I plus 36. Take the I squared out and put a -1. Form of a complex number. -36 plus 72I. That's the voltage of the inductor. So now we're going to find the voltage of the capacitor. Which is the same formula, voltage equals I times Z, Ohm's law. I is going to be what's given, plus 2I times the impedance of the capacitor, which is -5I. And then you distribute. So this would be negative 24 times would be a -120I minus 10I squared. So we get -120I minus 10 times -1, which would be a positive 10 minus 120I. You cannot simplify that. So it says, use the diagram of the electric circuit to answer the following questions. They want to know the total impedance. There it is. They want to know what is the voltage of each component. There it is. So that's it. Now, what if we want to check our answer? Like, what do we want to check it? I want to show you how to do that. Can I erase the?
Yep.
Well, they're telling us that the voltage of the entire circuit is 120 volts. So shouldn't that look like the sum of the 3 components? So shouldn't it look like 90 plus 48I plus negative 36 plus 72I plus 10 minus 1I. So can't we check it? So this would be, we could even line them up if you want, 96 minus 36 plus 10, the real parts. The imaginary parts would be plus 48I plus 72I minus 120I. So wouldn't this be 106 minus 36? And this would be, what is that? 120I minus 120I, and those cancel. So will the answer be 120? So we absolutely know that we did that right. So this is how.
Ms. Birch, I have a question.
Yeah.
For all of these, you multiplied it by 24 plus 12i, but for the last one, it's 24 plus 2i.
Yeah, it should be 12. Should be 12. So let's see what's going on here. How could I get that right answer? Isn't that weird? All right, let's see what I did. It should be 24 plus 12i. So the negative 120 is okay, but shouldn't this be negative what, 60i squared? And so that would be negative 60 times 1, which would be a positive 60. Yes? And so would this be 60? See how my work, guys? I just have to change parts of it. So 60 minus 120 would be, that's all the same. This should be 4872. The 60 should be here. So that would be what, 150? 120? Yes, that was a typo. Good catching it. And it turned out to be right. So I was looking at my notes and writing wrong. Cool stuff, right? So if you're planning on being an electrical engineer, you would have to deal with this type of stuff. Also, in college called quantum mechanics. They deal with a lot of imaginary numbers. It's a high level math. So, but what we're going to do today, we're going to work in the, and what I want you to do first is you're going to first circuit. So you're going to get a lot of practice with imaginaries. After you do this, you're going to start on the review for 3.2. Okay, so there's a review for 3.2. Don't get confused. The exam is only exam 3.1. So in your math teams, you're going to do this is part of lesson 3.2, but after that you're going to work on the review for 3.2. Assignment lesson 3.2, the other one is a review for exam 3.2. All right, anybody have any questions for me? Okay, well, let's continue working strongly in the collaboration. Your teams are doing good. After this exam on Tuesday, I'll probably be switching up the groups. So anyhow, I'll see you teams. All right. Okay, do you want to ask me any questions about the imaginaries?
Miss Birch, do we leave this meeting or no?
Yeah, yeah, so hold on just a second. Does anybody want to ask me about adding or multiplying numbers? Okay. Yes, you're going to leave the meeting, and this class ends at 2:10, so you have more than an hour to do a lot of work. So just make sure that if you have any questions, you get them cleared up with me. All right? Any questions about what you're doing? Okay, I'll see you in the teams.